Hey everyone, welcome to our lesson on 5.09 Fences and Outliers. So we're going to be looking at some more data sets to determine those fences and outliers. Vision, mission, and our Class Connect Code of Conduct. All right, so today's learning targets. I can represent data with a modified box plot. So we're still going to be looking at those box and whisker plots, but we're going to modify them a bit when we have an outlier. And then the second learning target is that I can determine whether a value in a data set is an outlier. Okay, so what is an outlier? Let's take a look. We talked about this in our last lesson. Remember that outliers are the values that lie outside the other values. They're separated from the main grouping of the data that we're given. So right here in this example, you can see most of the data here is clustered between 5 and 25, but then we have this one outlier out here of 50 that, if you notice, this is actually a modified box plot because we didn't include this as our maximum to show that we're not going to include it in our range of data. All right, so how do we calculate an outlier? So there's a way to actually determine if it's statistically an outlier, and to do that we're going to need our interquartile range. So we've got quartile 3 minus quartile 1, that gives us our IQR. An outlier is a value far away from most other values in the data set. It's all by itself. A value is commonly considered an outlier if its distance from either the first or third quartile is more than 1/2 times the IQR. The borders between outliers and values that are not outliers are called fences. So in a data set, the outlier in any number less than the lower fence or greater fence than the upper fence. Okay, and we'll talk about this a little bit more in some examples, so you'll get to see how it all works and comes together. So to find your lower fence, it's equal to your first quartile minus 1.5 times your interquartile range. And then your upper fence is your third quartile plus 1.5 times your interquartile range, your IQR. Okay, so those are going to be the formulas that we use to find that lower fence. So that tells us, okay, anything below the lower fence is an outlier, and the upper fence is going to say, okay, anything above the upper fence is going to be an outlier on the opposite end of the spectrum. So let's look at how we would apply this to an actual problem. Okay, so steps to finding an outlier. First and foremost, we have to put our data in order because we need to find the IQR. So we have to find our median and then our quartiles in order to find the IQR. So we're going to find the lower fence, and to do that we're going to use our formula, and we ask ourselves, are there any data points that are less than this? Okay, so if I had a set of data, let's say I had a box and whisker, I'm just making one up here. Okay, so let's say that my lower fence was here. I'd want to know, are there any numbers less than that lower fence? And likewise, if I have an upper fence, okay, I calculate the upper and lower fences using my formulas. Do I have any data that's above the upper fence? And if I do, then that data point or points would be considered an outlier. So that's what those fences are referring to. It means they're outside the range of most of the data. Okay, so let's go ahead and figure out if we have an outlier for this set of data. So this set of data is nice. They've already given it to us in order from least to greatest. So I'm going to go ahead and find my median by finding that middle number. So I'm just kind of coming to the middle here. So notice I've got two terms in the middle. I've got an even set of data. So 22 plus 29 and then divided by 2 is going to give me my median. 22 plus 29 divided by 2, and I'm going to get 25.5. Okay, so that's my median. Now, if you remember, to find those quartiles by hand, we take this whole group of data, and now we need to find the median of the front half. So the median of the front half, this is a set of 5, is just going to be that middle number. That's going to be that 14. And then I'm going to do the same thing on the other side to find my third quartile. Take that grouping of data, find that middle number. In this case, it's 36. So I can go ahead and find my IQR. Remember, IQR is Q3 minus Q1. So 36 minus 14, and I'm going to get 22. Okay, now that we have our Q1, our Q3, and our IQR, we can go ahead and see what our lower fence and our upper fences are. So I'm going to take my first quartile, so that's 14, minus 1.5 times 22. So that's what my IQR was. So I'm going to type that in my calculator, and I end up with negative 19 for my lower fence. Well, if I look at this data set, I don't have any negative values in this data set, so I don't have any outliers that are less than negative 19. So my lower fence doesn't give me an outlier. Now if I look at my upper fence, my Q3 was 36. My IQR is still 22, so 36 plus, and then 1.5 times 22, and I end up with 69. Okay, so that's my upper fence. So I want to see, is there anything above the upper fence? Any data points? So if I look at my data points, I notice right here that 70 is above, 70 is above that upper fence. So that is going to be my outlier, okay? So looking at the set of data, you might have assumed that 70 was in fact an outlier, but we can actually mathematically prove that using our upper and lower fences. So 70 is an outlier. Okay, so there is the first example. In your first few questions, you are going to have a TOD today. Your first few questions on the TOD are going to be like this. It's just going to give you a set of data, and they're going to ask you if there's an outlier or which numbers would be outliers in the set of data. Okay, so I have a second example here. It says the race times of 15 contestants rounded to the nearest minute are shown. We want to determine whether the data set has any outliers. So remember that first step whenever we are trying to find an outlier is to put that data in order. So luckily I have that for us already. And I'm actually going to show, since I did the first one by hand, I'm going to go ahead and do this one in the calculator. That's not what I wanted. Oops, I accidentally closed my calculator earlier. So once again, if you don't have this calculator, go get it, because it is amazing. And it will help you so much on that EOC and in class. Okay, so I'm going to go to data. I'm going to hit data twice. I'm going to clear out my list. Then I'm going to start entering in my numbers. So I'm going to enter in the numbers that were given to me to start. So I've got 45, 40, 36, 52, 49, 53, 56, 74, 36, 40, 42, 35, 60, 47, and 47. Okay, so notice if I go up to that 47, it says L1 15, so that means I've got 15 items in list 1, and there were 15 race times, and I tried to kind of watch my numbers as I inputted them to make sure they were correct. So I'm going to go to my second button and then hit data, and I get this one variable stats that comes up. Press 1, we're in L1, frequency we're going to use 1, press enter a third time, and it's going to give us all of those statistics. So N, that tells us how many items we have. The X bar here, that's our mean. S of X, that would be our standard deviation. So all that lovely info is already given to us. But what I need is my quartiles. So my Q1 is 40 and my Q3 is 53. So 40 and 53. Okay, and remember IQR is Q3 minus Q1. So that's going to be 53 minus 40, and we're going to end up with 13. Okay, so that lower fence, my Q1 is 40. My IQR is 13. I'm going to go ahead and type all that in my calculator. And I end up with 20.5. So that's my lower fence. So if I look at my data in order, that minimum value is 35. So I have nothing that's below the lower fence. Okay, there's no data on the lower end that's an outlier. So then we got to check to see what our upper fence is. So my Q3 was 53 and my IQR is 13. And this time I end up with 72.5. So do we have any data points above 72.5? Well, if I look at my, if I look at my data set that's in order up here, I see that I have that 74. So clearly we have an outlier of 74. All right, so that is how we statistically determine whether or not we have an outlier, using those lower fences and upper fences. If we have data below the lower fence, it's an outlier, and if we have data above the upper fence, it is an outlier. And again, in these first two examples, we just had one outlier, but it is possible to have more than one outlier. I just want to clarify that as well. Okay, now when we have outliers, if we were just to draw a box plot and show all the data and show our whiskers going to the min and max, we're not really getting a clear picture of the data because we're including the outliers. So one way to show the data a little bit more accurately is to modify the box plot, which is going to show that it's going to have your box and whisker plot, but it's going to show outliers with dots, and the whiskers are going to extend to the least and greatest values that are not outliers. Okay, so I'll show you what that looks like in a second. So this is the same as the last problem. And I'm going to go back. So 40, 53, 13. Okay, so same set of data. We don't need to find our info anymore because we have our quartiles in our interquartile range already for us. But we knew that 74 was an outlier. Okay, so instead of using 74 as my max, I'm actually going to put 74 as an X or a dot out at the end. I'll put it as a dot because it says dots up there. Sometimes you might see it as an X depending on the software program that made it. So my minimum value is going to be 35, but now my new maximum is going to become this 60. So when I start with my whiskers, I'm going to have my first whisker at 35, and then my max whisker here is going to be at 60. Okay, so my box plot is going to be contained within those two whiskers instead of using the outlier as my whisker for my maximum. Okay, so we know that my quartile 1 is at 40, so I'm going to go ahead and draw my longer marking here, and my third quartile was at 53. Just going to be right in the middle of 50 and 55, and I can draw my box and draw in my whiskers. Okay, now we didn't find the median of this data set initially, but let me see. If I pull this up from my calculator data, it told me that the median was 47, and if you did this by hand as well, you would have had to figure out the median to find your quartiles anyway, so you'd already have that data. So 47 is my my median, so I'm going to go ahead and draw that in as well. And if you'd like to, you can label okay, but that dot out there is showing that this point is in fact an outlier. We're not including it in that modified box plot. All right, so how does an outlier affect the mean? We talked about this in the last lesson, but we're just going to go ahead and refresh our memories really quick. So the following data plot shows the number of runs scored by the Frankville Rattlers baseball team in their last 15 games. So remember, when we have an outlier, most of our data is clumped together, and then we've got one lonely outlier over here. okay? So if the outlier was removed, what's going to happen to the mean? So if you think about this set of data, this 7 is going to pull, remember that the outlier pulls the mean towards the outlier, okay? So right now the mean is being pulled in this direction, okay? So if I took the outlier away, if I took this away, the mean then is going to go back towards the set of data. So instead of being increased in this case, it's going to be reduced because it's going to be brought back towards this grouping of data. So B would be the correct answer for this case. Now this is not always the answer, because if you were to take this box plot and you were to flip it, let's say that your outlier was on this set of your data, okay, over here, and then your grouping of data was over here. In this case, my outlier would have been pulling my mean towards the outlier, which would have been a decrease. If this is 0 and this is, let's say, 10, it's pulling it towards 0, where if I were to eliminate that outlier, my mean is going to be pulled back into the other direction, which would be greater than. So you have to look at the set of data to see how the mean would change. It's not the same. It's not always that the mean is going to be reduced. It just is when your outlier happens to be on the greater end of your data set. And this is actually the calculations. So if you wanted to actually look at the data and find the mean and the with and without, you could see. So the mean with the outlier ended up being 1.87, but when we took it away, notice it got smaller. It was 1.5. So you could also put all those values into your calculator, find the mean with both to figure that out, but you can do it just by looking at the graph as well. Okay, so I believe this is our last example, and you have one like this on your TOD quiz if you choose to do this one. So it says, which data set is represented by the modified box plot? So one way you can do this is you could type in all of these different data sets and find your min and your max and your quartiles and figure out, draw 4 box plots, but we're going to see if we can eliminate any of these first. So the first thing I notice is that I have this outlier here, and it looks to be at about a little bit more than 60. So if I look at this first set of data, I notice I have this 61. Okay, so I've got that outlier, and my minimum value looks to be at about, well, I'll say like 22-ish, maybe 23. So if I look here, notice I've got this data point of 15. Well, I don't have anything marked at 15. There's nothing there. So this could not be an option. All right, so that's just me taking a look to see what values that are in my data set that match the box plot. Okay, so I'm going to go ahead and then look at my second set of data. Change my color. Okay, so this next time, I'm looking for that 61 again. So if I scroll through here, I don't see that 61 anywhere. I see a 50 instead. And that is not representative of the data because it doesn't include the outlier. So this next set of data, I've got the 61. And then I want to look for like that 22. That looks pretty good. Oh, I think I made a, no, I guess I did make a little bit of a change on this last one. Okay, and then this last one, I've got this 61 and this 22 as well. So I'm going to narrow it down between these two. So now, unfortunately, I just have two big clumps of data, and we actually have to figure these out. So the way that I would do this is to use my calculator. If you don't have a calculator to do this, you're going to have to order these by hand and find your quartiles to match and to see what actually, Nope, I don't think that's going to help us. So let's go ahead and pull up my calculator again. Oops. I'm going to go into data. I'm going to clear. So this first set, and really we should only have to do one of them, and if it's the right answer, then we're good. If it's the wrong answer, it should be the other one. Okay, so I have all of my data in. I'm going to go second stat, one variable statistic, enter, 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 and we're going to scroll down to look for, okay, so our min 22, that looks great. My first quartile, that 27.5. Well, this looks to be more about 26, so let's double check a couple others. We got 34 for the median, that looks okay. Third quartile, 39.5, that is possible, but I'm going to say that that first one probably doesn't match up right there, that 27.5. And if we look at the difference between these two sets, there's really only two tiny differences, the 24 and the 27, and then the 29 and the 26. So I'm going to go ahead and eliminate that third choice, but just to be sure, I'm going to change this to 27. And then my other value that changed was that 29. There we go. I'm going to change that to a 26. We're just going to compare that really quick. So 26.5, that looks a little bit better. That's closer to that 25. So I'm going to go ahead and say that choice D would be our correct answer. So I'm going to get rid of that choice, and choice D would be our correct answer. So this one takes a little bit longer to figure out, just because you have to go ahead and test your two options at the end there. All right, so really quick this week, my circles didn't quite line up. We had that quiz for 5.07. You should have already watched that lesson. We've got that Unit 5 test coming up on Thursday. We'll have a review for that. And then we start Unit 6 on Friday. Remember that there is no Raise Your Grade Tuesday or Wednesday this week because of teacher professional development. So we'll see you all on Thursday morning. But here is your ticket out the door for today's lesson. So you can go ahead and grab that password and complete your TOD after watching this recording. Hope that you all have a great day.